Hello everyone. Now I'm here talking about our project, and our project title name is Optimal Placement of PMUs in Power System Network for Voltage Stability Estimation under Contingencies. It is to develop a real-time voltage stability estimation by using the optimal placement of PMUs. Our content is abstract introduction, voltage stability, existing system drawbacks, proposed system, advantages and applications, phasor measurement unit, voltage stability based contingency ranking, optimal placement of PMUs, voltage stability assessment using PMUs, 14 bus system, and finally conclusion. And voltage stability has been considered as an important trait of power researchers. And first, we need to maintain the voltage stability with the placement of phasor measurement unit at the few selected locations. Contingency have been ranked based on voltage stability margin, and this is the distance between the base case operating point and the nose point. Basically, PMUs have been placed in the system based on results of binary integer linear programming run under systems. And mainly, we are considering these case studies on the IEEE 14 bus system, the help of the power system to analysis toolbox software. Technology have paid a significant attention to utilize it in power system stability monitoring and control. And phasor measurement units by phasor measurements units can be utilized to resolve the various issues pertaining to power system. The applications of PMU technology in monitoring, control, and protection of the power system is well documented. Voltage stability has been considered as an important threat to power researchers and utilities since last few decades. With the placement of phasor measurement units, a few selected selections, it may be quite possible to monitor all the stability of power system network. Here we are proposing the optimal placement PMUs. Consider the impacting voltage stability based on under contingencies have been based on the voltage stability margin. Okay, existing system and its drawbacks. Several voltage stabilities includes current practices in power system. These indices can be monitored by the operator to access the proximity of the system. Voltage instability. So one of the widely used indices for the stability monitoring is the maximum loadability limit of the transmission network, and the existing system drawbacks are local monitoring, phasor angle measurements, analog measurements of PMUs has been considered considering the impact of voltage stability based on critical contingencies. PMU locations have been decided based on results of binary linear programming for critical contingency cases. Proposed PMU's placement algorithm is able to effectively estimate the voltage stability. Its advantages are phasor angle measurements. It is able to measure the angles and wide area monitoring, digital measurements, and basically applications are there. Power system, wide area monitoring system, wide area control application, and the power system protection. PMUs. For the system using PMUs, the following observability rules are applied to make the system observable. And the optimal placement rules are the four buses with the PMS, voltage and current phasors for all the incidents branches are known. These are called the direct measurements. If voltage current and current phasors at one end of a branch are known, then voltage phasors at the other end of the branch can be obtained. These are called as pseudo measurements. And finally, if the voltage phasors of both ends of a branch are known, then the current phasor of this branch can be obtained directly. These measurements are also called pseudo measurements. For the zero injection bus in an N bus system, we have uh, the formula voltage stability, making the voltage stability by using the PMUs. So because of that, we need to assessment the PM voltage stability of your PMUs. Identification of critical buses is necessary as such buses need fast to control action to ensure the voltage stability. And mainly sensitivity divided by d dot have been calculated for all the buses for the system in that case, and all the stability based on critical contingency cases and wide pattern of load increases uh, In case in that we are using the formula, the K constant is taking as a 0 0.2, 0 0.5, 1 point, and finally 1.2 respectively. Proposed approach of PMU's placement for estimation of voltage stability margin was tested on standard IEEE 14 bus system. Okay, na? PMU's placement for estimation of voltage stability margin was tested on the IEEE 14 bus system. Here we can see the MATLAB screen. అంతే కదా. Before going to that, we have to run the system in power system analysis toolbox. We have to install the in MATLAB. So whenever we open the lag అవుతుందా? We are opening the command window and text the pset and text the and please enter the
అవన్నీ మనకొద్దు
ఏం
సర్క్యూట్ పెట్టి సర్క్యూట్ ఎక్స్ప్లెయిన్ చేయి
14 bus system on pset toolbox. The 14 bus system consists of with two generators at bus number 1 and 2, three synchronous condensers at bus number 3, 6, and 8, and 20 transmission lines including 3 transformers. The system has a zero injection bus at bus number 7. The power flow and determine and settings, and we can click on the data. We can click on the data file, and we can get uh, the we can run this. We can put the load file as the as our system. Here we can keep here, and power, here is the continuous power flow. We have to click on this computation for the solver. This lag pass, all the results are came here on the static report, and at each buses we have to observe here, and we need to observe the voltage stability and voltage magnitude profile. It's a good, it's not like not bad. Next, observe all the current of the reactive power and active and reactive powers. We need to observe. And the values are based on voltage contingency ranking and observability analysis. It is observed from all the things, the results of programming else bus number 2, 4, 5, 6, and 9 as the location for improve the uh, voltage stability and making the stable the system. Number of PMUs at few locations, and the numbers are 2, 4, 5, 6, and the 9 location. The finally this paper, this project is suggested to an optimal placement of phasor measurement units to monitor the voltage stability of power systems and the change in the operating conditions. PMUs have been placed based on results of binary integer linear programming run for the system. Voltage stability based on critical contingency cases. And here we are using the PSAT lab, PSAT toolbox in the MATLAB. By using that, we easily can go find out the power flow and whatever we want, and based on the power system uh, properties